Okay, so this is a rate of change problem, and it is a calculator problem, which they may incorporate some aspect of a calculator on your test, but they're trying not to. So I still want to look at it because the concepts and the ideas are wonderful, and you only really need a calculator for part T. So our focus could be on parts A, B, and C. So it says we have hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t is given by the differentiable function c, where t is measured in minutes. Selected values of c of t can be seen in the table above. Use the data in the table to approximate c prime of 3.5. So if we are trying to approximate c prime of 3.5, that is like finding the slope between the points to the left and to the right of c prime. So if we're given a table and not a function, we're finding slope to find derivative. So we're going to look at c of 4 minus c of 3 over 4 minus 3, which is 12.8 minus 11.2 all over 1. And again, here's where I think if this were on this year's AP test, since it's non-calculator in a sense, the numbers would just be a little bit nicer. We are, in this case, left with 1.6. And then it says, using correct units, explain the meaning. So what does this mean? Well, C prime represents the rate of change in ounces in the cup over time, because ounces are our T value up top, time is on bottom. So this represents ounces per minute. So it's 1.6 ounces per minute. Okay, part B. Is there a time, and now look, you have to be careful. This is a smaller interval. We are only talking about from 2 to 4. Is there a time from 2 to 4 at which the derivative equals 2? Okay, time closed interval derivative equal to a number. This is M B T, if I ever heard it. So, is there a time? Well, how do we determine that? MVT says the slope of the secant equals the derivative at that point. So in this case, we're saying the derivative at that point is equal to 2. So we want to know, does the slope equal 2? So we're going to find the slope of c of 4 minus c of 2 all over 2. So c of 4 is 12.8 minus c of 2, which is 8.8. Oh, that's so nice. So that's 4 over 4 minus 2, which is 2. 4 over 2 is in fact 2. So, because it is a continuous closed interval, asking for if a slope of a secant equals a derivative, it is an MVT. So it says, is there a time? The answer is yes. How do we know? We know by MVT that there is at least 1 point in which t from 2 to 4 will equal 2. use a midpoint sum. All right, so this is a Riemann sum question with 3 subintervals of equal length. So that means my n value is 3. My formula is b minus a over n. So b is 6, a is 0 over 3. So that means my subinterval lengths are 2. So I'm separating it here, here, and there. It says use a midpoint sub with 3 subintervals of equal length to indicate the values. So basically what that means then is I am using the point 1, 3, and 5 as my midpoints. Because here's rectangle 1, rectangle 2. Sorry, I should draw it in the middle of my boxes. 1, 2, 3. Therefore making 1, 3, and 5 my midpoints. So area is just length times width, but this one says our widths are 2. So we have 2 times the quantity 5.3 plus 11.2 plus 13.8. So again, that's all my heights times a width of 2. So that gives me 60.6. So use the midpoint sum with 3 subintervals of equal length indicated by the data in the table. And now it says to approximate the value of 0 to 6 of c of t dt. So the approximation would be 60.6. And then because it represents the area under the curve, that would mean that this is in ounces per minute. All right, and last but not least, the amount of coffee in the cup in ounces is modeled by B of t equals 16 minus 16e to the negative 0.4 t. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So if we are trying to find the rate at which it is changing, that is really just a fancy way of saying what is the derivative at 5. So b prime of 5, well, the 16 would cancel. We know that that then becomes negative 16 e to the negative 0.4 t times negative 0.4. So negative times a negative creates a positive. And we get that this derivative is negative 6.4 e to the negative 0.4 t. And then we would just plug in 5. So you get negative 6.4 e to the negative 0.4 times 5, which becomes negative 6.4 over e squared. And this would be in indicating units of measure, ounces per minute. All right, so that sums up question 2 for AP free response review. Again, table, rate of change, slope of the secant, MVT, key concepts of AP Calc. Good luck.